In this video, we will be looking at one method of how to solve for the point of intersection in a linear system. And the method that we're focusing on today is called substitution. So I have all the steps on the side for us, and we're going to follow them. But really, the whole thing of substitution is that we want to take our two equations and mash them together to create one equation where we can solve for one variable. So our first step is to isolate for a variable if needed. But if we look at our first linear system here, we have y equals 5x minus 12 and y equals 3x plus 18. We already have an isolated variable, and what I mean by that is that one of your equations is y equals or x equals. So here we do have y equals 5x minus 12. So I'm going to take that 5x minus 12, that's equal to y, and replace y in the second equation with that expression. So I'm going to sub in the first equation into the second. So what that's going to look like is, instead of writing y equals 3x plus 18, I'm going to replace y with 5x minus 12, and then I'll write the rest of it out. So this used to be y. And once I've done that substitution, or I've done that swap, I only have one variable left. It's all about the x's. And we know how to solve this because this is now just a regular linear equation. I'm going to do a swap where I bring the x's on one side and the constants on the other. So I have 5x, and when I bring the 3x over, it becomes negative. And then I have positive 18 plus 12 because the 12 switches signs. And when we collect our like terms here, 5 minus 3 is 2x, 18 plus 12 is 30, and then we can divide both sides by 2 to get x equals 15. So this right here is the x coordinate of your point of intersection, and we're still missing the y coordinate, so we have to definitely solve for that. So step one was to isolate, which we didn't have to worry about in this example. Step two was to mash those two equations together by doing some substitution. And step three was to actually solve the equation. At this point, we're going to do one more substitution. We're going to take this x value for 15 and sub it into either equation 1 or 2. I'm just going to go into the first one. And my first equation tells me to do y equals 5x minus 12. But instead of x, I'm going to put 15. And now I just clean this up. 5 times 15 is 75. And 75 subtract 12 is 63. So there's the y coordinate. And now I can write my therefore statement. Therefore, the point of intersection is 15, 63. And we're always welcome to do a left side, right side check. Now, I did my solving for y in equation 1. So to do a left side, right side check, I'm going to do my left side, right side on equation 2. And this is optional for sure. So the left side of equation 2 is y, and the right side is 3x plus 18. So I'm going to replace y with 63, and I'm going to replace 3x with 3 times 15 plus 18. And then 3 times 15 is 45, and 45 plus 18 is 63. Our numbers match, so yay, we did that correctly. So a left side, right side check is an optional thing to do unless it's specified, but it is a nice way for you to check your work. Okay, let's try another example. So step one is to isolate. But if we already have a variable isolated for, we're lucky. And we do. In the second equation, I see that y is equal to x plus 1. So I'm going to take that x plus 1, and I'm going to find y in the first equation, and I'm just going to swap it in or substitute it in. So instead of 2x plus y, I'm going to write 2x plus x plus 1 equals 7. So this x plus 1 used to be the y, but we replaced it. And now I'm going to bring the constant to the other side to join the 7, and it will become negative. 2x plus x, or 1x, is 3x, and 7 subtract 1 is 6. Final step is always to divide out that coefficient, and I got 2. And then at this point, your choice, you can plug this into equation 1 or 2, whatever makes you happier. I think equation 2 will be the easier one, but you can definitely go in equation 1 as well. So y equals, and then instead of x, I'm going to put 2. So x plus 1 becomes 2 plus 1, and that's 3. So therefore, our point of intersection is 2, 3. Okay, let's try another one. 3x minus y equals 10, x equals 3y plus 14. So notice here we have x isolated for, and x is equal to 3y plus 14. So I look at my previous equation, or the one above. Here's the x, because x is what's isolated for. So I'm going to have 3, and then instead of x, I'm going to open up a bracket and write that 3y plus 14, and then write the rest of it. Okay, so it was just this portion here that was replaced with this. So this used to be the x in the equation. So at this point, I want you to pause the video, finish solving for y here, and once you get your y value, try to plug it into either equation to solve for x as well. Then come back to check your work. All right, so we should distribute the 3 in. 3 times 3 is 9y. 3 times 14 is 42. And now 9y and y stay together. The 42 goes on the other side, so that we have 9y minus y equals 10 minus 42. And now 8y equals negative 32. And we can divide both sides by 8, and you get y equals negative 4. And now you can plug into either equation. I'm going to go into equation 2 again, just because x is already on its own. So 3 times y, or 3 times negative 4, plus 14. So 3 times negative 4 is negative 12. And negative 12 plus 14 is 2. Okay. So therefore, the point of intersection is 2, negative 4. And that's it for this one. And you can always do a left side, right side check on the first equation here, because I did solve for y using equation 2. All right, let's try some more. All right, so we have 2x plus 5y equals negative 18, and x plus 2y equals negative 6. So you will notice here that we don't have an isolated variable. Like, none of our equations are x equals or y equals, so we have to do that ourselves. Now, when we choose the variable to isolate for, we always want to choose the variable that has a coefficient of 1. That way, it's a quick one-step maneuver. X is the only variable on its own, so that's where I'm going to isolate from. I'm going to take the 2y and bring it to the other side. So x equals negative 6 minus 2y. Now, this is what x is equal to. I go to the equation that I haven't touched, which is the one at the top, and then I'm going to do my substitution, or do my swapping. So instead of writing 2x, I'm going to write 2 times that expression, and then I'll write the rest, plus 5y equals negative 18. So again, this is from that isolated equation. I have combined or mashed my two equations together. And once you do that substitution, now it's just some solving. So let's distribute the 2 in. 2 times negative 6 is negative 12, and 2 times negative 2y is negative 4y, and then plus 5y equals negative 18. and we'll bring that constant to the other side because we're trying to get the variables on one side and the constants at the other, and make sure when you swap things you change the sign. So now -4 plus 5 is 1, so I just have y, and then -18 plus 12 is -6, so here we are. There's the y coordinate of our point of intersection, and you can take this and sub it into either of your original equations. So I'm going to take it and I'm going to sub it into my second equation. So my second equation says x plus 2y, but instead of y, I'm going to write the -6 that I just got equals -6. So I'll clean it up. 2 times -6 is -12. And now we can bring the -12 to the other side. So -6 plus 12 is +6. So therefore, the point of intersection is 6, -6. All right. For the next one, again, it will require some isolation on our part. So again, we want to choose the variable that has a coefficient of 1. We can choose either y, but +1 is the easiest. So if I'm choosing this, I'm going to bring the 5x to the other side. So y equals 12 subtract 5x. So now I can take this equation, 12 minus 5x, which represents y, and replace it with the y in the second equation that I haven't touched yet. Now just a reminder that the y has a -1 in front of it. So I'm going to have 3x subtract 1 times, here's the 12 minus 5x, equals -4. So here is what I swapped. And at this point, you will solve. And to get rid of your brackets, we are distributing the -1 in. So why don't you go ahead and try to finish this question off and then come back to check your work. Okay, so you should have 3x subtract 12 plus 5x. All the signs change. The x's stay together while the -12 moves over. So that's 8x equals 8, and then we can divide both sides by 8. And now we can sub this into either equation. I'll just go into equation 1 this time just to show you it's okay. You choose whatever equation makes you happier. So the first equation is 5x plus y equals 12. So 5, and then instead of x, I'll put 1 plus y equals 12. 5 times 1 is 5. And then that 5 I can kick to the other side. Changing the sign. You make one little sign mistake in here, it messes everything up. So therefore, your point of intersection is 1, 7. All right, last one that I want you to try on your own. So we have 4x plus y equals -3, x minus y equals -7. So here we actually have two options. You can isolate for this y, because it's easy to just bring the 4x over. You can even isolate for this x by bringing the -y over. The choice is yours. Let's just, for the purpose of doing this together, let's isolate for this x. Okay, so why don't you pause the video, isolate for x, and try to do the substitution on your own. I just want you to try this and come back to the video once you've done that original initial setup, just to make sure you're on the right track before you continue. So when you did the isolating, you should have positive y minus 7 because the y changed signs. And now we can take this y minus 7 and put it in for x in the equation I haven't touched just yet. So I'm going to have 4, and then instead of x, y minus 7, and then plus y equals -3. So this is what I replaced in that first equation. Okay, if you did that, great. If there's something that went wrong in the substitution, see what you did wrong, maybe the signs, maybe the equation, fix it. And now again, I want you to pause the video and just finish this question off and find that point of intersection. So when you distribute the 4 in, you get 4y minus 28 plus y equals negative 3. When I bring the negative 28 over, it becomes positive 28. So 4 plus 1, 5y's. Negative 3 plus 28 is 25. And when I divide both sides by 5, I get 5 for y. And then you can plug it into any equation. I'm just going to go into the second one, but you could have gone into the first, it doesn't matter. And we have x minus y, so x minus 5 equals negative 7. Isolate for x by bringing the negative 5 over, and the negative 5 becomes positive. And if we simplify that, we get negative 2. So therefore, the point of intersection is negative 2, 5. Make sure when you're writing your point of intersection, it's always x comma y. So again, for substitution, step 1, isolate. And remember, isolate for the coefficient of one variable. Step 2, substitute to mash your equations together. Step 3 is solve for that variable. Step 4, do another substitution wherever you want. Step 5, solve, and then write that therefore statement for the end. And that's it for substitution.